Hey everybody, in this lesson we're going to talk about calculations between mass and moles. So using molar mass, we can create a conversion factor to help us now relate between mass and moles. So how can we use molar mass as a conversion factor? Well, we know that molar mass has the unit grams per mole. And because of that, it relates mass and particles. Because moles is a unit for particles. So for example, if we have carbon, carbon, as we remember, is 12.0 grams per mole. We can write this as 12.0 grams over 1 mole. Or we could write this as 1 mole over 12.0 grams. And that now allows us to use it as a conversion factor. So let's look at this first example. If we look at, for example, 4.89, we will see that this is 4.89 moles per CO2. So what we have here is we have 4.89 moles, 4.89 moles of CO2. Okay, we gotta multiply by the molar mass of CO2 to find the mass of CO2. So we gotta look at CO2. So CO2 has one carbon. So we look at our periodic table, we have one carbon. So that's 12 molar mass. Plus we have two oxygens, which means we add 16 plus 16. The molar mass of CO2 ends up being 44 grams per mole. 0.0 grams per mole. So how can I now put this so I could cancel my moles and get grams out of this? Well, I could just put it where 44.0 gram goes on top, and 1 mole of CO2 goes on the bottom. And that way my moles of CO2 will cancel out, and I'm left with just my grams. So now if I punch this into my calculator, 4.89 times 44, I get the mass to be 215.16. Now, we now look at the correct number of sig figs. Conversion factors don't really have sig figs unless they're stated in the question. Our sig figs are always from our original question. So we always want to, because we're multiplying, we always round to the least number of sig figs. Well, in that case, how many sig figs does this number have? This number has how many? 3 sig figs. Because it has 3 sig figs, our answer should also have 3 sig figs. Because that, our answer actually rounds to 215 grams. That's our final answer. So make sure you always keep track of your sig figs or know how many sig figs to round to. It usually comes from the original question. Okay, let's look at the next example. How many moles of O2 are there in 75 grams of O2? Okay, so we have 75.0 grams of O2. What's the molar mass of O2? Well, if one oxygen is 16, the two oxygen will mean that's 32.0 grams per mole. Okay, so where should my 32 grams go? Where should my 1 mole go? In this case, my 1 mole should go on top. My 32.0 grams should go on the bottom because that way my grams will cancel out. And what I'm left with is just moles. So now I punch this in my calculator, I get 75 divided by 32, and I'm going to get 2.34375. But this is not the correct answer yet because there's too many digits. I gotta round to the correct number of sig figs. In this case, this is 3 sig figs, so I should round to 3 sig figs because my conversion factors actually have infinite amount of sig figs. Because this could be written as 1.000 repeating, and this could be written as 32.000 repeating because they're precise. They're accurate beyond that. So what we're left with then is 3 sig figs, so this should round to 2.34 moles. That's what we should be rounding it to. Our next example right here is what's the molar mass of carbon dioxide if we have 0.85 moles and it has a mass of 23.8 grams. We're trying to find molar mass. Molar mass has a unit of grams per mole. Well, do we know the amount of moles that have carbon dioxide? Yeah, we have 0.85 moles. Do we know the mass of this carbon dioxide that has this many moles? Yeah, it's right there, 23.8. So we can just plug these in to to solve. And what we get here is, so we divide 23.8 grams by 0.85 moles, and we should get the molar mass. And we get the molar mass of carbon dioxide being 28.0 grams per mole. Now, why is it 0.0? Because, again, we want to round to least ever sig figs. In this case, it is 3 sig figs and 3 sig figs. So this is 3 sig figs. And if we look at a periodic table, carbon monoxide is CO. That's the chemical formula, which means it's the molar mass of one carbon and one oxygen. One carbon is 12, one oxygen is 16. We have a molar mass of 28. That's what we have here. So hopefully you get enough practice on how to use molar mass as a conversion factor. As always, make sure you keep yourself safe and healthy, and I'll see you soon.